Okay, so it says, use the table to answer the following questions. I like this problem. I don't know, maybe you don't, but I think it's a good problem. All right, letter A, what are the zeros of this function? The zeros of the function. If we talk about zeros, there's some other terms that we sometimes use, which would be the roots of the function. If I put roots in instead of zeros, does that help at all? Yes. Jalen says -2 and 4 because they give you x coordinate values with a y value of 0. So that means they are going to be on the x-axis, right? And with a parabola, well, we don't know for sure. Does it say? It doesn't really say. But in looking at it and figuring it's probably a parabola since this test is on quadratics, yeah. So the zeros are going to be -2 and 4. And if they tell you to write them as an ordered pair, then it would be -2, 0, and 4, 0. Yes. Yes. If I have a pencil left, if there's no pencil back there in that red canister, check on my desk. There's erasable pens, some pens. I mean, I am literally out of pencils. So then B says, write an equation in factored form for the table. Remember to find the A value. Factored form. Now, the reason we give you A first is because we're going to use these values in A to help us write factored form, right? So, factored form, does anybody remember what that looks like? A comes first. Not H, not H, not K. You're thinking more vertex form. It's going to be root 1 times x minus root 2. That is factored form. Now, that's not the factored form we're writing, but that is what we're looking to do, okay? And did we not just find the roots? Well, how convenient. Yes. So I'm going to say y equals, I don't know what A is yet, but I know this is going to be x minus, here's my one root, -2, minus -2, times x minus my root of 4. And I know I can't have a double negative there, so I'm going to make this plus a positive. So that's going to be x plus 2 and x minus 4. Okay? But I don't know what my A is here yet. How would I solve for A?
Did you make that a plus sign?
For x plus positive 2?
Yeah.
Yes, I did. Because you cannot subtract a negative. You can't subtract a negative. Subtracting a negative makes it positive. How could I solve for A? Are there other x and y values that I have that maybe would be on that parabola also? One what? What do you mean? Yeah, all of these are other values, right? But let's try to use one that's relatively simple, right? Do we want to use any with fractions? No way. So don't use the fractions. But here's one. It's got a 0 and a 4. So let's substitute 0 in for my x's and 4 in for my y's and solve for A. So y, which is 4, well, I'm going to write out y equals A times x minus root 1 times x minus root 2, just so you can see what's going on. So 4, substituting that value in, is equal to a times my x value is 0 minus the negative 2 becomes plus 2, and 0 minus 4. So this stays 4 equals, I need to do what's in parentheses first. So this a is going to stay the same. 0 plus 2 is 2. And 0 minus 4, my bad, is negative 4. So 4 equals, what is a times 2 times negative 4? Negative 8a. And we're trying to solve for a, right? So let's isolate a, get a by itself. Right now it's being multiplied by negative 8. So I'm going to divide by negative 8. Those negative 8's cancel. A is equal to negative 1/2. So that is going to go right up here to where my A is in front. And there is your equation for this quadratic in factored form. So we try to help you out. If we're asking for the zeros, you have to know those are also called your roots. They have 2 other names, and I cannot for the life of me think of what they are, which is really irritating me. Maybe solutions? That seems, maybe. Your roots, your zeros, your solutions. And so use what we give you before to help you find whatever form is the next in the problem. So it says, where is the vertex of this function? Where is the vertex of this function? Is it always going to be the middle of a chart? Okay, so talk more. Tell me more. You've got a good idea. So what are you thinking my vertex is? Okay. So why do you think this is the vertex? I'm not saying you're right. I'm not saying you're wrong. I just want to know why. Be confident. Because you're right.
I don't know how to explain it, but like, because it goes, I don't know, like, because it's like starting point, it goes up and then down, you know, kind of graph.
Yeah. Okay, I think I understand what you're saying without you really saying it. It's a parabola, right? It's symmetric on both sides. So here at negative 2, I have a height of 0. Here at 4, I have a height of 0. Okay? Here at negative 1, I have a height of 5 divided by 2, which is 2.5. Here I have 2.5. Here I have a height of 4. Here I have a height of 4. And what is 9 divided by 2? It's 4.5, right? So this is the highest point. And it doesn't have a matching other half. So this tells you that it is the vertex. Okay? So 1 9/2 is the vertex. So then it says, write an equation in vertex form for the table. Remember to find the A value. All right. So guess what? We found the vertex. We're going to use this to help us do the vertex form. Who remembers what the vertex form is? And we give you these formulas, I believe, on the test. Does anybody remember? Y equals. Uh-huh.
X minus H.
Mm-hmm.
Parentheses
So close. So close.
I get the square.
Right, with the square right there. Okay. So, what part of this do we have? Well, we know in general we're going to have the x and y's, right? We're not filling those in. So, y equals, we got to solve for the a value. We know this is going to be x minus, do we know the h value? What is it? Yeah, remember this is your vertex right here. You did the hard work. So your h is 1, and then we're going to square it. And then plus k is going to be plus 9/2. So we need to solve for the a value. Okay? And I'm trying to think, but we're going to play this out because I'm not thinking. Okay. Or maybe not. What is the vertex? Okay. So how would we find A? How would we find A? Any ideas? Anyone? Anyone? Interesting. Anyone? Quadratic formula is going to give me x value. We have x and y values. So these are points already on our parabola. Okay?
Should we substitute?
Substitute what?
Something for the y,
And something for the
x.
x. Yeah, so let's pick some values again that are going to make it easy. Okay? So I would say let's pick 0 and 4 again. Wow, I picked the wrong one there. So 0 and 4 says 4 is equal to a times my x value of 0 minus 1 quantity squared plus 9/2. You fractions. 4 equals a times, what is 0 minus 1? -1, right? Squared plus 9/2. 4 equals, what is -1 squared? Because we have to do order of operations, so I have to do parentheses first, then exponents. What is -1 squared? What is -1 squared? 1, and 1 times a is just a, right? So a plus 9/2. What is 9/2 as a decimal or something, or a fraction, or mixed number? 4.5. So a plus 4.5 gives me 4. So subtract 4.5, subtract 4.5. A equals -1/2 or -0.5. Which, guess what? That's what our a value was before. So we should have just kept that the same, right? So a is -1/2 out front. So here is vertex form. What is the y-intercept of the function? Yes. Why is that true? Right, it is next to 0. And I did a wrong thing. So the y-intercept is 4 because you're looking at 0, 4. I said it was 9/2, but that only works when you're in standard form because I'm going to get some other stuff here. If I substitute 0 in here, I'm going to get 0 minus 1 is 1 squared is 1. 1 times -1/2. And -1/2 plus 9/2 gives me 8/2, which is the 4. That's what I didn't do. I assumed it was just the C value, but you can only do that when your A value is 1. So yes, that is 4. And lastly, write an equation in standard form for the table. Remember to find the A value. So unfortunately, this one, there's nothing before it, not immediately before it, to help us with standard form. However, there are things before in the problem that would help us. How do we get to standard form? What does standard form look like? Anyone? Okay, so looking back at some of these other answers, how could I get to standard form? We do have the A value, and it is, okay, -1/2, right? Yeah, that should be a negative down there. So -1/2. X squared, we know it's got to be there, right? Plus B. I don't know if we have the B. What else could I use? Could we use the roots? Which one of these is the one I'm looking for? I think I want this one. The roots themselves? Or how about this factored form? I mean, when this is written, what is that telling you to do? That really blocks out a lot, doesn't it? When I say y equals -1/2 quantity x plus 2 times quantity x minus 4, I even said it. What is it telling you to do? Multiply, right? So what if we double distributed those two factors out front and then took that answer and multiplied it by -1/2? Wouldn't that give me standard form? Do you think it would? It should. So let's write it down here. Oh, got the wrong one again. So y equals -1/2, I'm just rewriting it, x plus 2 times x minus 4. We're going to double distribute, right? And figure out what I get here. So y equals -1/2 times, I'm just doing these two first. So x times x is x squared. X times -4 is -4x. And then starting with the 2, 2 times x is 2x. And 2 times -4 is -8. If I simplify what's in the middle and common, I get x squared, -4x, and 2x is going to be -2x minus 8. I now need to distribute this -1/2 with everything. So y equals -1/2 x squared. Negative times negative gives me a positive. 1/2 of 2 is 1x. And then -1/2 times negative is positive. Half of 8 is 4. So my standard form is right here Rewrite it above. Negative 1/2 x squared plus 1x plus 4. Okay. All right. When does this function equal 4? When does this function equal 4? What does function mean? What is a function? Function is kind of another word for the y value. When is the y equal to 4? When is the function equal to 4? Give the order pairs. Well, where do we have y equals 4? 0, 4, and 2 and 4. Where is the function equal to 5 halves? Negative 1, 5 halves, 3, 5 halves. If I said, where is the function equal to 0, that's your roots. That would be negative 2, 0, and 4, 0. Okay, so the function is where the y coordinate is whatever value you're looking for. Okay? All right. I like that one. That's a good exercise. What else would you like to go over? 3A? Okay, 3A. Ooh, 3A. Rewrite the following into vertex form. Complete the square. Read the following into vertex form. Complete the square. Identify the vertex and y-intercept. Okay. So here we have, for 3A, y equals 3x squared minus 18x plus 8. We need to, it says, change it into vertex form, and they're giving us a hint by completing the square. So we better do completing the square. All right, and I know I've done this a couple different ways. It's essentially the same, but a little bit different. This C value, I used to say, let's take it to the other side. I'm going to keep it on the same side, but I'm just going to put it further out. Okay? Even before I do that, though, do I have a greatest common factor? No, I do not. All right, so I'm going to rewrite this as y equals 3x squared minus 18x, and this plus 8, I'm going to put way over here, because when you complete the square, we're trying to come up with a new C value, okay? My new value that I need to put in here is done by taking your B value and dividing it by 2, and then squaring it. So my B value is negative 18 divided by 2, which gives me negative 9, right? Wait a minute. Is it 2A? Let me look. Okay. One other thing I forgot. You can tell this is not my favorite. It's not Miss Bieshke's favorite either. As I look at these, this only works when A is equal to 1. When A is equal to 1. So between these two, I can factor out what? A 3. So y is equal to, I'm going to factor out a 3, which means I'm dividing by 3, and I get x squared minus 6x. Okay. All right, and then I still have this plus 8 way over here. Now, to complete the square, I need to take, as I was saying before, take your b value, divide it by 2, and then square it. So my b value is -6 divided by 2 gives me -3, and -3 squared is 9. So I'm going to add 9 right here. And because this is part of this quadratic, I have to end it with that parenthesis, that right parenthesis. Now, even though this looks like I have only added 9, because I have to distribute the 3, I really have added 27, correct? I want to balance out adding 27 by subtracting 27 because I really don't want to add anything new. Okay? So, my next step is y equals 3, and this is, can't think of what they call it. It's not a perfect square. Is it a perfect square? It is a perfect square, I guess. But you take the square root of your x squared, which gives you the x. You use the same operation that's right there, which is the minus, and you take the square root of the last term, the positive value, which is 3, and that squared, that becomes your square. And then these back here are both constant, so we put those together. 8 minus 27 is going to be -21. And this is our vertex form. So vertex form, y equals 3 times x minus 3 quantity squared minus 21. So from that, what is my vertex, my h and my k value? 3 and -21. That's a 1. Yeah. 3 and -21. What is my y-intercept? What is it? 8. How did you get that? Okay. So the y-intercept, remember the y-intercept is on the y-axis, which means x is equal to 0. So when he substitutes 0 in for your x's, like right here, you get 0 minus 0. We added 27 and then we subtracted 27. So this 8 is all that's left. So the y-intercept is 0, 8. 0, 8. Okay. All right. Would we like to do B also since it's completing the square? I'm pretty sure you guys are doing that tomorrow, so let's practice that one again. I could use the practice, that's for sure. All right, so y equals x squared plus 4x plus 3. Have you guys got all that down so that I can just erase it all and have more room? Yeah. Okay. Clear ink. All right, so first of all, do I have a GCF of any of all of those or just the first two? Yeah, and that's kind of complicated too. Maybe it's just because, is that my phone? Probably. Okay, hang on. Because our a value is already 1 and we have the x squared there. Oh. I never know. How you can tell who that was. Recent. 214 on 420. Pamela. Yeah, this is Miss Thede. It's who? Oh, hi. I'm in the middle of teaching. Yeah, that's fine. All right. Okay, thanks. Bye. Okay. Whew. All right. So x squared plus 4x. We really want to keep the x's though. So looking at the coefficients, I don't have a greatest common factor. I know looking at the first two we do, but we want to keep the x's there. We need those, okay? So we don't have a greatest common factor. We're going to say y equals x squared plus 4x. We're going to put this plus 3 way over because we want to find our new c value. Okay? That means I'm going to take b, divide it by 2, and then square it. My b value is 4. 4 divided by 2 is 2. Square that 2, and that gives me my new c value of 4. So I'm going to add 4 here. Excuse me. But I don't want to end up adding 4 without the same time subtracting 4, because 4 minus 4 is 0. I don't want to add anything new. All right, but rewriting this, I get y equals, this is, gosh, I wish I could think of what it's called. It's like a perfect square, but I don't remember what it's called. Anyway, you take the square root of the first term, the square root of x squared is x. You take the same sign here, which is plus, and you take the square root of 4 here, which is 2, and you square it. That is your square. And then back here, you put together your constants. 3 minus 4 is going to be minus 1. This is your new vertex form. Yes? Why did I drop it? I didn't drop it. If you work this out and say x plus 2 times x plus 2, and if you work it out like this, it's x squared plus 2x plus 2x plus 4. It's just the way it looks. It looks like we dropped it. Okay? All right, so that is your vertex form. Y equals x plus 2, quantity squared, minus 1. So what is my vertex here? Be careful. -2, -1, very good. Because it's a positive 2 and it's always minus something. So it's minus the negative. And here's the -1. That's my y coordinate. What is my y-intercept? So that's going to be where x is equal to 0. So think of that. Go back up here. And you can put it in your original one even, because we haven't changed anything. We're just changing the form of it. So if I put zeros in for my x's, what's my y-intercept? 3. 0 squared, zero's out, plus 4 times 0 is 0, plus 3 is 3. So 0, 3. Okay. Any others quickly that I might just share quickly? I don't know. Or ones that you're like, I really wish we had gone over this one. So take a look at this. Maybe go through the book, review. Do you remember if the discriminant is negative? How many roots is that? If the discriminant is 0, how many real roots is that? If the discriminant is positive, how many real roots is that? Do you remember? It'd be 2 here, 1 here, the bounce, and this would be no real roots. Do you remember what the discriminant is? If we ask for the discriminant, that is just b squared minus 4ac. It's the part underneath the square root, okay? The Wile E. Coyote one, that's a good one to look over. What else? Whatever method you choose. Could be Xbox, could be quadratic function or quadratic equation. Might be the square root one. Did we talk about and get to the square root one? So if we have like something like 4 squared and you have something squared over here, take the square root, x minus 2 equals 4, solve both ways, something like that. Okay. So look over that. Can you identify the roots just looking at a graph? Once you have the roots, could you write it in factored form? We kind of just did that, solving for A. There's a lot on here, but I think you're very capable of doing it too. Just look over your review. I will collect that tomorrow. Okay. Did you get it all done? Okay, it's on my desk? Perfect. All right. Yes. I am staying after. Yeah. All right. Well, good.